A very good morning to all of you. I am Manita Malik, Assistant Professor in Doon Valley Institute of Pharmacy and Medicine, Kannad. Today I am here to discuss about the topic that is evaluation of crude drugs. Yesterday, in the previous lecture, I have discussed about what is evaluation, why we need evaluation, and two methods of the drug evaluation, that is the morphological, which is also known as organoleptic, and second one is the physical evaluation method. So I hope you all are now able to know about what is evaluation. Evaluation, I am repeating again, evaluation contains the three terms, that is the identity, quality and purity, and it is necessary to check the basic adulteration. Is it your drug is adulterated or not? And here are methods of drug evaluation: organoleptic, microscopical, chemical, analytical, physical and biological. And we have discussed about the organoleptic and physical evaluation method. In the today's session, we will discuss about the chemical evaluation method, physical, analytical and biological. So organoleptic is all about the morphology, and physical evaluation method is all about the physical properties like its melting point, boiling point, viscosity, moisture content, optical rotation, refractive index, what is ash, total ash value, acid insoluble, sulfated ash, extractive value. Through all these methods, you can identify whether your drug is adulterated or not. And today, I'm going to start about the third method, that is the chemical evaluation method. In the chemical evaluation method, as it is clear from its name, it is somewhat related to the chemical constituents, right? So in this method, you have to determine whether your drug is adulterated or not in the context of your active constituents. And the chemical evaluation methods includes qualitative chemical test. It can also include the quantitative test, chemical assays also. So the determination of the active constituent in a drug by chemical test is referred to as chemical evaluation. This is the basic definition of chemical evaluation. And chemical evaluation methods includes the qualitative, means what quality of your drug contain, constituents, what quantity, in which quantity, in amount कितना है, ये आप कैसे पता लगा सकते हैं? By doing various chemical tests. Like we have discussed about the chemical classes. In the chemical classification, like if your drug contains alkaloids, then you have to do alkaloidal test. If your drug contains glycosides, then you have to do the glycosidal test. Like this, there are many categories and the many tests. Then chemical assays, assays means the percentage purity. Then the instrumental analysis. Note down that in this method, I am also covering about the instrumental methods, that is analytical methods also. So you can combine chemical and analytical method in this method only. And it's also, I mean, the isolation, purification and identification of active constituents. And these all are comes under the chemical methods of evaluation. Or you can also say it also includes the following methods like instrumental, chemical constants, individual chemical tests, as I mentioned, for alkaloids, alkaloidal tests, for saponin, saponin test, for glycoside, glycosidal test, for carbohydrate, carbohydrate test, microchemical test for very minute quantity constituent present. So firstly, I'm going to discuss about the qualitative chemical test. What do you mean by quality? Quality means what type of quality आपके chemical constituent कौन सी quality का है? Like alkaloids है, glycosides है, tannins है. अब alkaloids क्या होता है? Alkaloids means the basic substances, nitrogen containing substances. Glycosides क्या होते हैं? Glycosides, as its name sorry, contains glyco. Glyco means sugar. It means glycosides are those compounds which upon hydrolysis gives two parts. First one is the sugar part, that known as glycone, and second is a glycone part, that is the non-sugar part. And then tannins, Carbohydrates, it can also contain lignins, volatile oils, fixed oils, flavonoids. There are so many, lot many classification, chemical classification, and you have to do respective tests of them. Then comes the example of identification of constituents, like this constituent is present or not. For example, copper acetate test used in the detection of colophony. This is a specific test present as an adulterant for the resins, balsams, and waxes. We have discussed about the resins. These are the gummy secretions which are obtained by after incision, and these are the end products of metabolism. Then the Halfens test for the cottonseed oils, Bodion test for the sesame oil, in the olive oil. You have to detect if adulteration in the olive oil, then you have to do these tests. Then the test with acetic acid and nitric acid for balsams in copaiba. Then when or reagent for the argon. This is a name test, when or reagent. This is a very specific test for the argon. This is the only test you can say, when or reagent. Then comes the Vitali Morin test for the tropine alkaloids. As there are also many tests of the alkaloids like Dragon Drops test, Mayer's test, Wegener's test, Hager's test, etc. Like in Dragon Drop, there are different composition. It consists of the potassium bismuth iodide solution. Then the Mayer's test, in the Mayer's reagent consists of the potassium mercuric iodide solution. Wegener's consists of the iodine in potassium iodide solution, and Hager's reagent contains the saturated solution of picric acid. And all these tests have a specific inference that all these tests gives the different colors. Like in Dragon Drops, there is a reddish brown color. In Mayer's test, cream color. Wegener's also reddish brown. Hager's test gives a yellow color due to the picric acid. Like iodine test for starch, if you have to found that if your compound or your drug is contain starch or not, then just you have to put a iodine solution drop. If it changes into blue color, then this is a quick test for the detection of starch. Like in carbohydrates, the Molish test is very basic test. Molish reagent, which it is consists of alcoholic alpha naphthol and some concentrated sulfuric acid, and it gives purple to violet color ring. And examples of the carbohydrates like glucose and sucrose. अगर आपको आपके सैंपल में पता करना है कि कार्बोहाइड्रेट प्रेजेंट है कि नहीं, तो सबसे पहले आपको मॉलिश टेस्ट करना होता है, लाइक ग्लूकोज एंड sucrose के लिए. Other tests for carbohydrates are Selinov's test, then osmogen formation test also. Iodine test like for the identification of starches, sport test for the identification of, and the sport test is for the identification of fixed oil. This is the difference between the volatile and fixed oil. अगर आप कोई भी volatile oil का spot लगाते हो, then it can evaporate because it is a volatile in nature. But अगर आप fixed oil का spot लगाते हो, तो आप जिस भी जगह पे लगाते हो तो वो अपना मार्क छोड़ के जाता है, मीन्स स्पॉट छोड़ के जाता है, because it can't evaporate. Then the Murex test for the purines basis are the examples of this evaluation. So this is all about the qualitative chemical test. Hope you all are understand now able to understand what is qualitative chemical test. This is a specific for the chemical classes, and these tests provide information regarding the nature of active principle. Active principles means आपके कंपाउंड में कौन सा एक्टिव कॉन्स्टिट्यूएंट प्रेजेंट है, आप इन क्वालिटेटिव केमिकल टेस्ट से बहुत इजीली पता कर सकते हैं. नाउ इट्स टाइम फॉर डिस्कस द क्वांटिटेटिव केमिकल टेस्ट. क्वालिटी में तो आपको पता चल गया कि किस क्वालिटी का, कौन सी क्वालिटी का आपके ड्रग में कॉन्स्टिट्यूएंट प्रेजेंट है. नाउ क्वांटिटी, quantity means amount. Quantity chemical test, these tests give the value or amount of active constituent in the crude drug. कितने amount में आपका drug में active constituent is present. Examples include now the saponification value, acid value, iodine value. Like in the evaluation of resins, sulfated ash acid value can determine what amount of resin your drug contains. In the balsam, acid value, saponification value. In the volatile oils, as acetyl value, acid values. In the gums, methoxy determination and volatile acidity. So what is saponification value? This test is basically for the detection of lipids. the number of milligrams of the potassium hydroxide, that is number of milligrams of KOH required to saponify 1 gram of fat under the condition specified. This gives the value and it gives the measure of molecular weight of the crude drug. Then comes the ester value for volatile oils. What is ester value? It is a number of mgs, milligrams of the KOH required to saponify the esters. Saponification, the esters in 1 gram of the substance. Then comes the acid number. Acid number is used for the resins such as acid value in the resins and balsam. Balsams are the acids which contains the balsamic acid, like the benzoic acid, cinnamic acid. These all are useful in evaluation of a drug by means of chemical treatment. Then the third is chemical assays. We have discussed the qualitative test, quantitative test. Now the third one is the chemical assays. So chemical assays, what are chemical assays? In this we have to determine purity. These tests give an approximate value of total phytochemical constituent in a crude drugs. Total phytochemical constituent totally, and include acids for the alkaloids, resins, volatile oils, glycosides, vitamins, and other constituents. Few examples I've got it here. These are the assay of total alkaloids in the belladonna herb. Belladonna is Atropa belladonna and belongs to the family Solanaceae. In this, you have to determine total amount of alkaloid, whether it is tropine alkaloid, whether any other kind of alkaloid. We have to assay of the alkaloid content. Then total alkaloid and non-phenolic alkaloid in the ipecacuanha, ipecac, it is an it is emetic drug. Then the alkaloid in strychnine in Nux vomica. Nux vomica is Strychnus nux vomica Loganaceae family. You have to determine the alkaloid strychnine. कितना आप में strychnine present है Nux vomica में? Strychnine is the main active basic constituent in Nux vomica. Then resin in the jalap and the vitamins in the cod liver oil. So all the results obtained can conclude the presence of inferior or the exhausted drug. आपको पता चलेगा इसे आपका drug inferior है या exhausted है. Inferior means it is of substandard quality and exhausted means from the drug you have deliberately exhaust means extract the all the active constituent, and by providing the absence of the acid constituent it will suggest complete substitution of a worthless article. ऐसे करने के बाद आपको पता चल जाता है बिकॉज इफ अगर नक्स वोमिका में स्ट्राइचनिन ही नहीं है, स्ट्राइचनिन इज द बेसिक एक्टिव कॉन्स्टिट्यूएंट, अगर स्ट्राइचनिन ही प्रेजेंट नहीं है आपके नक्स वोमिका में, देन just by doing a chemical assay you can suggest whether your drug is worthless or it is worthful. So if strychnine is absent, then you can suggest easily can say the this nux vomica is adulterated. So this is all about the chemical evaluation. Now the instrumental analysis. Instrumental analysis means in this we have to use some instruments. इंस्ट्रूमेंट्स में आपका यूवी आ सकता है, आईआर आ सकता है, एनएमआर आ सकता है. यूवी मींस अल्ट्रा वायलेट, आईआर इंफ्रारेड, यूवी, आईआर, एनएमआर, and it also includes the chromatography techniques also. So there are basic very different types of chromatography. Instrumental analysis, these are used to analyzing the chemical groups of phytoconstituents using the chromatographic and spectroscopic methods. What is chromatography? Chromatography basically it represents a group of methods. It is a group of methods for separating molecular mixture that depends on the differential affinities of the solute between the two immiscible phase. Between the two immiscible phase, chroma means color. Through this, from the color, we can identify our constituent present in the solvent. So one of the phase in this is the fixed bed of large surface area, which is called as stationary phase, while the other is the, it can be a gas, it can be a liquid, that is the mobile phase. So the stationary phase may be a porous or a finely divided solid or a liquid, and that has to be coated as a thin layer on an inert material. So this is the basic of the thin layer chromatography. And various type methods includes in chromatography are paper chromatography. In this you have to use paper, Whatman paper. It can be radial. Then the thin layer chromatography, TLC. In this you have to use the TLC plates or slides. Then the gas chromatography, HPLC or HPTLC. HPLC means high performance liquid chromatography. It is a very useful in qualitative and quantitative analysis of pharmaceuticals, and it is a practical and it combines the art of chromatography with a quickness at a moderate cost. So HPTLC, next is HPTLC, high performance thin layer chromatography. This is a major advancement and which require very shorter time and better resolution of results. And the basic difference between the TLC and the HPTLC is only in the particle and the pore size of the solvents. So these all are the instrumental analysis chromatographic methods. Gas chromatography, this separates the volatile substances by percolating a gas stream over a stationary phase. The basis of separation in GLC is the gas liquid chromatography is the partitioning of sample in and out of the film of liquid spread over an inert solid. So now the spectrophotometric method, it contains the UV and visible chromatography method, UV and visible spectroscopy. It means the ultraviolet and visible absorption techniques. Then the infrared, mass, and NMR, nuclear magnetic resonance spectroscopy. So this is all about the chemical evolution method. Now it's microscope time for microscopical, or you can also say it's the anatomical evolution. In the morphology, we discuss about the morphology, that is the external characters, but in the microscopy, with the help of microscope, you can identify your drug by seeing its anatomy, that is internal structure. So microscopic evaluation, this is a indispensable in the initial identification of herbs as well as in the identifying even the small fragments of the crude drug or powdered herbs. इस माइक्रोस्कोपिक मेथड से आप इवन पाउडर माइक्रोस्कोपी भी कर सकते हो, और बिल्कुल ही कोई भी स्मॉल फ्रेगमेंट्स आपके क्रूड ड्रग में प्रेजेंट है, लाइक इंसेक्ट्स हैं, एनिमल फीसिस हैं, कोई भी मोल्ड फंजाई कुछ भी आ गया, तो यू कैन इजिली आइडेंटिफाई विद द हेल्प ऑफ द माइक्रोस्कोप. बिकॉज एवरी प्लांट पोजेसेस ए कैरेक्टरिस्टिक टिश्यू स्ट्रक्चर. हर प्लांट का अलग अलग स्ट्रक्चर होता है, लाइक उसका अरेंजमेंट कैसा है, उसके सेल वॉल्स कैसी हैं, ठीक है, उसमें सेल्स कैसे हैं, विच कलर के हैं. तो अब बहुत सारे हमारे पास लाइक लिग्नेंट स्टेन्स रेड और पिंक हो जाता है अगर आप थोड़ा सा 1 ड्रॉप फ्लोरोग्लुसिनोल डालते हैं विद अ कंसंट्रेटेड HCl, तो इट स्टेन्स रेड एंड पिंक. देन यू कैन इजीली आइडेंटिफाई द योर क्रूड ड्रग कंटेन्स द लिग्निफाइड टिश्यूज और नॉट. Then if in mucilage is stained pink with ruthenium red, and N15 iodine solutions stains starch and amylose blue. So these are the basic, very basic tests for identification in the microscopy, and this method also allowed more detailed examination of a drug. More detail, why we are saying more detail? Because in this minute structure of the drugs are studied, and it can be used to identify organized drugs by their known histological characters. Known histological means their histology, their anatomic characters are already mentioned in the pharmacopoeias in the standard box. And this can be done, this technique can be done by powdering. You can do powder microscopy, you can do TS like cutting in the thin sections of the drug, or preparing a macerate also. And the techniques in this include, in the microscopy, you include the linear measurements. Linear means a scale, determination of a leaf constants. Then the quantitative microscopy are also used in this type of evaluation method. So first one is a linear measurement. Linear measurement means including the size. जब आपको कोई किसी चीज का साइज मेजर करना है तो आप उसमें माइक्रोस्कोपी यूज करते हो. उसमें आपका एक स्केल, ऑकुलर माइक्रोमीटर एंड स्टेज माइक्रोमीटर यूज करके आप अपना साइज निकाल सकते हो. स्टेज स्टार्च ग्रेन्स का, लेंथ विड्थ उसका, आपके फ्लोइंग फाइबर्स की, ट्राइकोम्स एटसेट्रा, ये चीजें सब आप माइक्रोस्कोपिक इवेल्युएशन में कर सकते हो. डायमीटर क्या है? फॉर एग्जांपल आपने इपिक्यूना का एक स्पेसिफिक डायमीटर होता है स्टैंडर्ड ड्रग का. अगर आपने आपका सैंपल में इपिक्यूना में एडल्ट्रेशन है कि नहीं, यू कैन जस्ट put a powder of the drug of the roots and examine under the microscope. If it is matches with a standard value, then your drug is of standard quality, otherwise it is adulterated. Likewise, the diameter of a starch grain in the cassia bark distinguished from the cinnamon and detects senna stalk in the powdered senna leaf. अगर आपके सेना लीफ का पाउडर आपने दिखाया है तो उसमें डिफरेंट कोई कॉन्स्टिट्यूएंट्स आएंगे जो कि आपके सेना में नहीं आते हैं, एंड दिस इज बिकॉज ऑफ द सेना स्टैग. The size of the stomata also, this is also a very good parameter, like the size of the stomata. What are stomata? These are the basic used for the breathing of the leaves. Stomata in the leaves of the Barsoma betulina distinguish it from the other species of Barsoma. And the diameter of phloem fibers aids the detection of cassia in the cinnamon. अगर केसिया बाग को सिनेमन बाग में मिला दिया तो आप फ्लोएम फाइबर्स की हेल्प से डिटेक्शन से आप डिफरेंशिएट कर सकते हैं. And the width of the vessels help to detect clove stalks in the powder cloves also. Likewise, you can measure the diameter, various diameters for the identification of your drug. This is comes under all under linear measurements. Then the microscope can also be used for the quantitative evaluation also. Quantitative means number. Like this contains specific histological features in a leaf, stomatal number, stomatal index number, vein isolate number, palisade ratio, quantitative microscopy, like this. This is, here it is showing a picture of stomata. These are the open pores through which leaves can breathe out, and it is also helps in the exchange of gases. So the average number of stomata present per square millimeter of the epidermis is known as stomatal number. This is the basic definition of stomatal number. What is, आप एक पर स्क्वायर एमएम का एपिडर्मिस का लीफ से उतार लेते हो, पर स्क्वायर एमएम में आप कैलकुलेट करते हो कितने आपको नंबर ऑफ स्टोमेटा काउंट कर रहे हैं. सो यू कैन इजिली सो दिस स्टोमेटास, एंड दिस इज आल्सो ऑलवेज अ स्पेसिफिक. So stomatal number is a relative, a constant for a particular specific species of the same age. अगर सेम एज का प्लांट है तो उसमें सेम ही आपको मिलेंगे. एग्जाम्पल धतूरा, अगर एपिडर्मिस आप धतूरा की पील करके उसको माइक्रोस्कोपिकली एग्जामिन कर रहे हो तो उसमें 141 आपको स्टोमेटा मिलेंगे. Then stomatal index. What is stomatal index? It is a percentage proportion of the number of stomata to the total number of epidermal cells. Stomatal index में आपने क्या करना है, percentage proportion निकालना है of the number of stomata to the total number of epidermal cells. And stomatal number varies. Stomatal number कभी कभी vary हो सकता है, but stomatal index is the relative constant for a given species. For example, in atropa in lower epidermis, stomatal index is 20 to 23, and here it is given the formula for calculating the stomatal index number. This can be calculated by using the formula S upon E plus S into 100. What is S in this? S is the number of stomata per unit area. Means आपने 1 mm square of epidermis में calculate करना है कितने stomata आपको visible है, and E is the number of epidermal cells in the same unit area. तो उनको डिवाइड करके इंटू 100 करेंगे तो आपके पास स्टोमेटल इंडेक्स आ जाएगा. नेक्स्ट पैरामीटर है आपका वेन आइसोलेट नंबर. वेन आइसोलेट क्या होता है? वेन आइसोलेट इज द यूज्ड फॉर माइन्यूट एरिया, इट रिप्रेजेंट minute area of photosynthetic tissue, and vein islet number is defined as the number of vein islet per square mm of the leaf surface. Number, how many number of vein present in the per islets are present in the per square mm. For example, in this, how many vein islets are present? You can calculate this, and it is also constant for a given species of a plant. For example, Cassia sena as a vein islet number is 26. Then comes the palisade ratio. What is palisade cells? These are just below the epidermal cells, and their also function is to absorb a light for a photosynthesis also, and their shape is like this. So palisades ratio is the, it represent the average number of palisade cells beneath one epidermal cells. एक epidermal cells के नीचे कितने आपके palisade cells आ रहे हैं? Using 4 continuous epidermal cells for the count. आपको count के लिए 4 epidermal cells continuous में चाहिए, and it is determined from the powder drug. So palisade ratio you can calculate from the powder drug. Example are in Atropa belladonna there is a 6 to 10. So this is all about the qualitative, and now it is quantitative microscopy. What is quantitative? It is an important analytical technique for the powder drug, especially when chemical and other methods of evaluation, like we have discussed here, जैसे हमने अभी पहले डिस्कस किए कौन से मेथड, स्पेसिफिक केमिकल मेथड्स किए, फिर माइक्रोस्कोपी में आपने माइक्रोस्कोप की हेल्प से पाउडर माइक्रोस्कोपी किया, टीएस किया है, these specific histological features करें, stomatal number, like this. Now it's quantitative microscopy. Quantitative microscopy आप कब करते हैं? Especially when chemical and other methods of evaluation of crude drug fails as a accurate measure of the quality. इसमें आपका एग्जांपल आएगा लाइकोपोडियम स्पोर मेथड. लाइकोस्पोडियम स्पोर्स आर द वेरी कैरेक्टरिस्टिक इन शेप एंड अपीयरेंस. अगर कहीं पे भी आपको लाइकोस्पोडियम स्पोर्स दिखते हैं तो उनका बहुत ही डिफरेंट रहता है, उसका शेप कैसा है, उसका अपीयरेंस कैसा है. सो बाय कैलकुलेटिंग दिस लाइकोपोडियम स्पोर मेथड you can easily identify your crude drug. So this is a very important technique employed in identification of crude drug when chemical and physical methods are inapplicable. जब कोई और मेथड एप्लीकेबल नहीं हो सकता है तब आप अपना ये मेथड एप्लीकेबल कर सकते हो. क्या उनका लाइकोपोडियम स्पोर मेथड. एंड यूजिंग दिस one can determine the proportions of the substances present by means of the microscope using the lycopodium spore method, and this is basically for the powder drugs with a well defined particles. इसमें आप well defined particles आप calculate कर सकते हैं. This is specific for those. For example, starch grain को आप easily identify कर सकते हो, और single layered cells हैं, tissues हैं, and the area which may be traced under suitable magnification, or the object of uniform thickness, length of which can be measured under suitable magnification. जिसमें length भी आप measure कर सकते हो, उनकी thickness measure कर सकते हो under a suitable magnification, and actual area calculated are usually evaluated using this method. And this method you can also find adulterated starchy drugs by counting the number of starch grains. Number of starch grain अगर आपके per mg आप calculate कर सकते हो as per the आपका pure starch में कितना है, और adulterated अगर आपका है तो उसमें इतना नहीं है, तो you can say your drug is adulterated. So likewise in authentic ginger is if adulterated, one knows that ginger contains 286,000 starch grains per mg, and the amount used this as an adulterant can be calculated by using this figure. Like this is a standard figure, and by comparing with this you can identify your ginger is authentic or not. And here it is given an equation for the lycopodium spore method. For calculating this is the percentage purity of a drug you can calculate with the N into W into 94,000 into 100 upon S into M into P, where N is equal to the number of the characteristic structures. Number of characteristic structures, example, starch grain, which you can easily identify in the powder. In the 25 or 26 fields, you have to calculate in this. Then what is W? W is weight in mg of the lycopodium taken. आपने कितना लिया उसका weight. Then S is the number of lycopodium spore in the same 25 fields. Then M represent the weight in mg of a sample. आपने जो sample लिया उसका weight M, and W is the weight of lycopodium. M is weight in mg of the sample calculated on the basis of sample dry. Dry करने के बाद आपने 105 डिग्री पे dry किया, उसके बाद आपने sample का weigh किया. Then P, it is 286,000 in case of ginger starch grain powder. This is fixed for a specific drug, and lycopodium spore method can be used for the evaluation of powder clove, ginger, cardamom, nutmeg, and other umbelliferous fruit, because all these umbelliferous fruits contain the specific structure, and if the material is one of for which constant is not available, it is necessary to determine one by the preliminary experiment. So this is all about the chemical method and the microscopical method. Hope आप सबको ये समझ में आया होगा. In the next lecture we will discuss about the remaining methods, that is the biological method जो आपका एक रह गया. So thank you for watching the video.